Hi everyone! So we're going to be starting a new lesson all about rational functions. Rational functions is just a fancy way of saying that it's a function that's a ratio between two polynomials, or another fancy way of saying that it's a fraction with x's or variables on the top and on the bottom. So this first video we're going to learn how to simplify the rational functions, and then throughout the rest of the lesson we'll learn how to add, subtract, multiply, and divide. But let's get started with the simplifying. So when we simplify rational functions, the goal is to figure out what the top and the bottom have in common. And then once we figure that out, then we can cancel that out. So let's just start with this first example. It's 10x to the fifth over 15x squared. So when I think about what they have in common, I'm going to start with just the numbers or the coefficients, 10 and 15. So what do 10 and 15 have in common, or what can I divide them both by? Well, they are both divisible by 5. So what I'm going to do is I'm going to take a 5 out of the top and the bottom. Then, because I know we're going to kind of keep that there, and I promise that it'll make sense in the end, but because I know that 5 is divisible, the 10 and the 15 are both divisible by 5. Now let's talk about the x's. So we have x to the fifth on top, which really means that there's like 5 x's. I could write them out as x, and then x squared on bottom, which means there's 2 x's. So if I think about what they have in common, they have 2 x's in common, because the bottom has 2 x's, and the top, even though it has 5 x's, well, we know it at least has 2 x's. So what I'm going to do is write x squared on the top and the bottom. That's what they both have in common, a 5x squared. So if I were to take a 5x squared out of the top, I would be left with 10 divided by 5, which is 2, and then x to the fifth minus x squared, or divided by x squared, which really means that I'm going to take 5 x's and take away 2 x's, which would give me 3 x's left, so it'd be 2x cubed. That's what I have left over. Then on the bottom, if I take a 5x squared out, I'd be left with whatever 15 divided by 5 is, which is 3, but I wouldn't be left with any x's because I took the 2 x's out, so that's all I had, so I'm done. I don't have any more x's left. All right, so now I've factored the top and the bottom, or I've figured out what they both have in common. But now we have this 5x squared on top and a 5x squared on bottom. Because you have one thing on top, the same thing on top and on bottom, you can actually cancel them out. So the 5x squared on top, 5x squared on bottom gets canceled out, and I'm just left with what was left over, which is 2x cubed over 3. And this is my simplified answer. There we go. All right, so let's try another one. The second example is 42x squared over 35x cubed plus 14x. So once again, we're going to figure out what the top and the bottom have in common. Excuse me. This time, the bottom is a binomial, or it has 2 chunks instead of just one. So we have to be aware that when we're taking stuff out, we have to make sure that it divides along all of the chunks, or all of the terms. So the first thing we're going to talk about is the coefficients, or the numbers. We want to think about 42, 35, and 14. So what do 42, 35, and 14 all have in common? They have a 7 in common. So what I'm going to do is take a 7 out of the top and a 7 out of the bottom. Okay, now that we know that, we're going to talk about the x's. So on the top I have an x squared, and on the bottom I have x cubed, and then just an x. So like I told you, we need to make sure that it's common across all 3 terms, which means that we're going to end up taking an x, just one x out, because that 14x has the lowest amount of x's with just one x. So that's the smallest amount, or the biggest, I should say the biggest amount that I can take out. Okay, so now we have that 7x. Let's figure out what we have left over on the top and the bottom. So on the top, if I divide 42 by 7, I get 6. And then x squared divided by x, which really means I'm going to have 2 x's and take away 1 x, which is giving 1 x left over. Then on the bottom, excuse me, we're going to have to take a 7x out of both chunks. So if I do 35 divided by 7, I should get 5. And then x cubed take away x would give me x squared, because that's like 3 x's take away 1 x. Oh, sorry, I just said 2 and then I wrote 3. Let me try that again. Okay, and then the 14x, if I take away, divide by 7, I get a 2. 14 divided by 2 is 7. Or, oh my goodness, 14 divided by 7 is 2, I'm sorry. And then if I take away 1x, the 14x only had 1x to start with, and so it's just left as 2. And now we can take out the 7x's because you have a 7x on top, a 7x on bottom, so they cancel each other out. And my final answer is just what's left over, which is 6x over 5x squared plus 2. And we know this is the simplest answer because there's nothing else that we can take out. We took out the greatest common factor when we were taking out that 7x. If for some reason you took out something smaller and still saw that you could take something out again, that's totally fine. Do it again. Just in most of the time we want to try and take out the biggest number first. That way you don't have to do it multiple times. Okay, let's look at this third example. In the third example, you have x squared plus 7x plus 10 over 3x squared plus 6x. So if you notice on the top, this is a quadratic trinomial, which we can factor. So anytime you see something with like x squared, then an x, and then something without an x, that's considered something potentially that you can factor. So we're going to use the box method to factor just the top. So let me draw it out. And we always put the x squared or the first chunk in the top left box and then the last chunk in the bottom right box. The goal is to find two numbers that multiply to be the last number. So multiply to be 10 and then add to be the middle number, which is 7. So let's figure out two numbers that multiply to be 10 and add to be 7. So if I'm going to talk about the multiplication part, well, if I multiply to be 10, I can say 1 times 10, or I can say 5 times 2. Those are the only two things that multiply to be 10, which means that in order to add to be 7, I'm going to use the 5 and the 2. So I put a 5x in one box, a 2x in another box. It doesn't matter which box it goes in, but you do have to add the x's. And then we're going to say, well, what do the bottom two boxes have in common? Or what can I divide them by? I can divide them by 2. What do the top two boxes have in common? They have an x in common. What do the right two boxes, or the left two boxes have in common? They have an x in common. And then what do the right two boxes have in common? Or what can I divide them by? 5. So these on the outside of the box are my factors, which means I can rewrite the top as x plus 2, x plus 5. All right. So obviously that didn't necessarily help us in the way that we've been doing those first two examples because it didn't like take anything out, but we did rewrite it in a way that will be really helpful soon. So now let's talk about the bottom. On the bottom, normally for the first two examples we've been talking about, we need to make sure that we get the greatest common factor out of all of the chunks. But in this case, we're just going to factor the bottom. So what can I take out of these two bottom chunks? What do they both have in common? Well, they both have a 3 in common. I can divide both of those things by 3. And then they also have an x in common because you have an x squared and then just one x, which means you can only take one x. You can't take two x's out. So if I take a 3x out, then I'm going to be left with just an x because if I do 3x squared divided by 3x, the 3's cancel each other out, and then x squared minus 1x gives me just one extra x left. Plus, and then if I do 6x divided by 3x, the 6 divided by 3 gives me 2, but the x's disappear. So this is my factored form, or my factored form of the bottom. So now that I have it in factored form, I can actually cancel out what I need to, or what the top and the bottom have in common. And if you notice, they both have an x plus 2 in common, which means I can cross those things out. And what I'm left over with is my answer. So it's x plus 5 over 3x. So that one was a little bit different because we had to use the box method, but still it kind of works the same. You want to make sure that you factor out the greatest common factors if there are any, use the box method if you need to, and then cancel out whatever the top and the bottom have in common. Okay, let's look at this last example. This last example is x squared minus 5x minus 6 over 9x cubed plus 45x squared minus 54. So if you notice, the top, again, is that quadratic trinomial. And so I'm going to use the box method for it. Let's draw it right here. We're going to put the x squared up here, negative 6 down here. We want to multiply to be negative 6 and add to be negative 5. Okay, so 6, we can do 6 times 1 or 3 times 2. Now this one is a little bit confusing because both of these could work to add to be 5, but in order for it to multiply to be -6, only one of them can be negative, which means I'm going to use this 6 and 1, because if I do if I do -6 and a +1, I get -5 when I add, and I get -6 when I multiply. So I'm going to do -6x in one box, 1x in another box. Okay, what do the bottom two boxes have in common? They really don't have anything in common, so we're just going to put a 1. The top two boxes have an x in common. The left two boxes have an x in common, and then the right two boxes have a -6 in common. All right, so that's what the top turns into. Let me just write that out. X minus 6, x plus 1. All right, now let's talk about the bottom. On the bottom, I want to figure out what they have in common. So looking at all of those numbers are divisible by 9. But if you notice, they all have x's in common too. So what I'm going to do is take a 9x out of everything. All right, so when I take a 9x out of the front, I'm just going to end up with x squared. Then I'm going to have minus 5x, because 45 divided by 9 is 5, and then minus 6. All right, cool. So if you notice, we got stuck, or not stuck, but we ended up with another quadratic trinomial right there, which means we can factor that. We can use it the same way that we just did the box method on the top. We can do the box method on the bottom. And I'm really tricky because the same thing, the x squared minus 5x minus 6 ends up being on the top and on the bottom. And so the box method should end up being the same. We can double check that though. So I want to find two numbers that multiply to be -6 and add to be -5. Once again, -6 and +1, because -6 times 1 is -6, and -6 plus 1 is -5. So we're going to do -6x in one box, 1x in another box, and then again, because it's the same box method, it'll look the same on the outside as well, which means that I can rewrite this entire equation as x minus 6, x plus 1 on the top, and then on the bottom we have 9x, but then I'm going to rewrite the x squared minus 5x minus 6 that was on the bottom as x minus 6, x plus 1. All right, so this is in the factored form. Now we have to simplify it by canceling out what happens on the top and on the bottom. Notice you have an x plus 1 on the top, on the bottom. Great, that was easy. Then you also have an x minus 6 on the top and on the bottom, so those cancel out as well, which means we're just left with a 9x on the bottom. When you're left with just something on the bottom and nothing's left over on the top, we put a 1 on the top, because 1 times anything is still itself, so the 1 doesn't change anything, but now we can actually write the fraction. The simplified fraction is 1 over 9x. And this is our simplified version. Notice that it did simplify down quite a bit. And so simplifying these things really does help, especially when you're trying to do other things with them, like multiply or divide or anything like that. So try and simplify first before you do any of that. And that's how we simplify rational functions.